Let's look at 5A. There are only 2 questions in 5A, if I can get there. Okay, 5A. On a certain exam, the average of the scores was 50 and the SD was 10. Convert each of the following scores to standard units. So my X bar, or it could be mu. Do you guys know the difference? Do you know what X bar, the difference between X bar and mu? X bar is a parameter, which means it describes a population, everybody, and mu is a statistic which describes a sample. Now, for the purposes of this class, we're just going to say they're the same thing. We don't really care. Average. So X bar is the average of everybody, and mu is the average of the sample. And remember, statistics is the study of samples. If you know everybody, then it's not a statistic, it's a parameter. And our job is to understand statistics. Can we look at part of the people and then make guesses on the people entirely? That's what we're going to do. So, X bar or mu is 50, and then the symbol for standard deviation is sigma, or we'll just say SD, is 10. And then we have some scores, 60, 45, and 75. What would 60 be? 1 SD. So we would say plus 1. 45? Minus 0.5. 75? Plus 2.5. Does everybody get that? So once again, Chapter 5 is all about standardizing. We take a histogram that looks roughly normal, and we throw out the histogram and we replace it with the standard normal curve, where we look at SDs, right is positive and left is negative. Okay? All right. So if I had the scores, the standard scores, 0, plus 1.5, and negative 2.8, what would the test scores be? 50, 65, and 22. So that would be 50 minus 28. Is everybody good with that? Okay. If you get this, you'll probably be okay in this class. If you understand standardizing, it's the building block that we're going to use to do everything else we do. So if you understand standardizing, then you'll be just fine in this class. Okay. Question 2. Convert each entry on the following list to standard units. So I have 13, 9, 11, 7, and 10. What do I need to do? I need the SD and the average. So we put those in our stat. So just enter all those. Okay. And how do I find the average in the SD? Go into stat, calc, one variable stat. So I get X bar is 10 and my sigma is 2. Everybody understand how I got those? Okay. So 13 would be, so if I standardized 13, I would get plus 1.5. So my average is 10. So 13 is how much bigger than 10? 3. How many SDs is 3? 1.5. Nope, you always do this in terms of that. That's what standardizing means. So we're 3 to the right, correct? How many SDs is that? So if I were to do my normal curve, okay, this is 10, and this is -3, and this is +3, right? Or sorry, 2. Those are 2's. +2 and, oh my goodness, -2 and +2, right? I want to graph 13. So 13 would be 11, 12, 13. The question is, how many of these does it take to get here? 1.5 2's. So all you really have to do, you have to take your value and subtract the x bar and divide it by the SD. How you doing? So if you want to find the standard score, you would take 13 minus 10, and that's going to give you 3. So we're 3 numbers away from the average. Well, we need to turn that into SDs. So we sort of have a ruler of length 2. How many of those rulers does it take to get to +3? So it'd be 1 ruler there and half there. And it's plus 1.5 because we're on the right. If we were on the left, it would be minus 1.5. Okay? And I'm glad you asked, because you absolutely have to understand this. If you get lost later, it's because you don't get this. Okay, we'll try again. So, so how about 9? What is 9 going to give us? Minus 0.5. We are half an SD below the average. The SD is 2. The average is 10. So 9 minus 10 is -1. Cut that in half, and I get -0.5. Okay? 11 is going to be plus 0.5. Okay? 7, what is 7 going to be? -1.5. Do you get that? So how far away is 7 from 10? 3, to the left or to the right? It's to the left, so it's actually -3. How many SDs, how many 2's does it take to get to 3? A full 2 and half a 2. So it'd be -1.5. Okay? And then what about 10? 0. Okay? So the next question is kind of interesting. So it says, find the average NSD of the... Oh, wait. Sorry. What? So find the average NSD of the converted list. Okay, so everybody watch this. Yes? Oh, go ahead. Tell them. What is... So we ended with plus 1.5 minus 1, or sorry, minus 0.5 plus 0.5 minus 2.5 and 0. Wait, did I do it wrong? Oh. Okay. Does everybody get that? Hey, look up here. Yes, I am the most important thing in your life right now. So, if we look at this one converted was 1.5. This one converted was -0.5. This one converted is 0.5, negative 1.5, and 0. Okay, so we're going to put those in our calculator. Shh, and run the one variable stat again. This, let me plug these in and I'll talk about it. Okay. Now I go out and I do one variable stat again. And what do I get? The average. Hey, listen up, guys. Stop. Stop. The average is 0, and the standard deviation is 1. Are you surprised? No. No. That had to be the answer. I could have told you the answer before we even did anything. How do I know? How did I know that the average was going to be 0 and the SD was going to be 1? Turn to page 79. Look at page 79. The normal curve has an average of 0. So remember, our job in chapter 5 is to take this, which it might balance at, say, 120, and it might have an SD equal to 15, right? Our job is to throw that away. And what do I turn it into? I turn it into 0 with a 1, negative 1 and a 1, a negative 2 and a 2, and a negative 3 and a 3. Right. Does this ever change? No. The point is to force every normal curve to become the standard normal curve. So when we do that conversion and we take the average and the standard deviation, we will always get 0 and 1. That's what standardizing does. It forces whatever numbers you have to turn into 0 and 1. So I knew the answers before I even calculated it, but we calculated it to prove it. If you have converted to standard units, the average will always be 0, and the SD will always be 1. Yes? Well, so that's a really good question. Does standardizing ruin the fact that our statistics have numbers? No. Because as long as your data is relatively normal, we force everything to the same system. And the nice thing about that is, if you graph them, you don't have to change your windows. All of the rules for standardizing, we could do them in regular units. If I were doing test scores, I could do all of my calculations in test scores. But then if I wanted to look up, if I needed to look up areas, then I would have to do those areas in whatever units the test scores are in. Does that make sense? So instead of creating a different graph for every problem, we force every problem to the same graph. And as long as your information is normal, it works. If it's not normal, then it doesn't work. So if your histogram looks like this, then standardizing isn't going to do you any good. We have ways to deal with that, but if your histogram looks like this, yes. So it tailed like this. We do have a trick that will allow us to. Yeah. What we end up doing, is this normal? No. What we end up doing is we transform the data. So if the data is not quite normal, like incomes, Okay, we can do this little trick with our x-axis that will make it look normal. So right now, let's say this is thousands of dollars. So 10,000, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120. We can change our x-axis. So Malone, pay attention. Except you're distracting poor Bryn. So instead of going 10 to 120 by tens, we do this funny trick where we'll say this is from 0 to 1, and then this is 1 to 10, and then this is 10 to 30, and then 30 to, let's see, that's going up by 20, so 70, and from 70 to 120. So the x-axis is getting larger, and what that does is it pulls all of this information, and then it would be normal. But there's a problem because we have changed the numbers, so we do our calculations, and then we change them back. Does that make sense? No, it actually makes it allows us to use the rules we like with problems that it shouldn't work with. So it's kind of like you're working in inches and you convert to centimeters and you do all your calculations in centimeters and then you just convert back to inches. That's kind of what you do. And as long as there is a decent pattern in the data, well, because the normal curve won't work here. Right? If we do the regular SD on the original data, it doesn't fit. So it doesn't work. So what we do is, we have all of our numbers listed. We change these, and then it looks like this. And once it looks like that, we do all of our statistics. Right, all of that stuff. And then you get your answers, and then you convert your answers back. Okay, so that takes care of everything in 5A.